if you want the copy of the link. Okay, so I am given an equation now, and I'm asked, don't graph, don't do anything, just tell me whether it represents a function or a relation. Okay, so how will I address that? What should I do? Well, so I'm trying to adjust the camera here. So all I have to do is solve for y. And then I will know whether this is a function or not. When I solve for y, I move all the other terms to the other side. This is a positive term. When I move it to the other side, it becomes negative. I always present terms in descending order. Is this a function or a relation? The answer is, this is a function. How do I know it's a function? Well, I know it's a function because for every x value, I will determine only one y value, not more than one. So 0, 0, 0. That's how I evaluate. Let's say for x equals 1, negative 1 plus 3. So y equals 2. And I can continue forever. And I guarantee you that for every x, I will get only one y value. So I will say function. What about the following example? Let's say I have y squared minus 3x plus 2 equals 0. Again, I have to solve for y. I'm given this equation and I'm asked, hey, does y represent a function of x? Is y a function of x? That was the same question here. Is y a function of x? I said, I don't know. Give me a moment. I will I will solve for y, and then I will see. Yeah, it is. The same procedure here. I move all the terms that have nothing to do with y. When I move them from one side to the other, the only thing I need to do is change the sign. I did. But now, if you remember from the previous chapter, we have to take square roots. It turns out that we have two options. And it's a very simple example. Let's say when x is 10, 30 minus 2 is 28, but then y will be positive the square root of 28, and it will be negative the square root of 28. This makes the equation a function or a relation. Anyone, please.
A relation.
Of course. Thank you very much. It is a relation because it is sufficient to show that for a particular x value, I get two y values. And back to our little bubbles, that was the exact same situation. Imagine x equals 10, I got y equals the square root of 28, and I got y equals negative the square root of 28, therefore it's a relation, not a function. Okay, I would like to look at a couple of graphs and identify from the graph, so I can even graph it here. Because I'm afraid that you cannot see, it's too small. I should have somehow enlarged those. So I don't know if you can see. It doesn't matter. So let's suppose I have this graph. And I'm going to put some numbers in here. So negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and I have 2 here. I have 1 here. So this is our f of x. I jumped ahead and I said it's an f of x. That's the notation for the function. Is this a function, first of all? I should have waited and asked you, is this a function? Because maybe it's not a function. But is it?
Yes.
By the
function of x.
By the vertical line.
The vertical line test.
Excellent. By the vertical line test, this is a function. Excellent. we would like now to identify certain values from the graph. So let's say if I ask, what is f of 2? I'm going to say, find f of 2. What is given in this question? I'm asking you to find f of 2. What do we know? Do we know x? Do we know y? What do we know?
We know x.
Yes. Excellent. Thank you, Michelle. We do know x, that x is 2. Imagine, or just draw, this line. What type of line is it? What type of line is x equals 2?
Straight line.
Exactly, but it's a vertical line. Very good. It's a vertical line. So imagine, or just draw, the vertical line x equals 2. You realize that it crosses the graph in a point, and we will be able to read the y value. That's what f of 2 is. Can anyone tell us what is the y value when x is 2?
Is that 1?
That's it. Can anyone identify the ordered pair correctly that we read from? Which ordered pair did we read from?
2,
Exactly. Comma.
1.
2, comma 1. X first, y second. That is indeed the situation. Any questions, please, on this so far? What if now I change the question and I ask find x if or when f of x is 2? What is given now? What is given in this question?
Professor, I have a question.
Please.
I'm not understanding the difference between a function and a relation.
So the difference is that a function guarantees that each and every x value from the domain will have a connection, and there will be a unique connection in the y or in the range. Unique. So there is only a point 2 comma 4. There is no other point 2 comma 3 or 2 comma 10. Here there are 2 points, 3 comma 0, 3 comma 4. This is a relation. A function does not have that option. Each x value corresponds uniquely to a y value. The graph of a function looks like this, as an example. This one is basically 2 functions. It's this function, and this is another function. So a relation has 2 pieces. One, in this case, in my example. So a function and another function. And for a particular x value, we find 2 or more y values. So your concern is about the real life applications or of functions? Is that...
No, I understand it now.
So another example would be something like, I have you in my class and I want to measure everybody's temperature. So Melissa will have 1 temperature, not 2. Gianna will have 1 temperature, body temperature, 1, not 2. So each and every one of you has only 1 correspondent, your own temperature, body temperature, not more. Like the same thing with the weight. So each person has 1 weight. It may fluctuate in time, But the moment I put everyone on a scale, you only have one, not two. So that's a connection to functions. For each x, there is only one y. Now, here's another example. In a household, there may be 2 cars, or maybe 3 cars, right? So household, so let's say Nathaniel's household has 3 cars. So to one x, 3 different y values. It's a possibility in real life, but it's not a function. It's a relation. Is that better in understanding what the difference is between a function and relation in real life?
Yes, thank you.
Perfect. So let's go back. Good. Where are we? Good. So in this particular situation, we're asked now to find x knowing that f of x is 2. So what is given now? Because based on what is given, I will know how to continue. What is given now in this question? Here, x was given. But what is given here?
Is it y?
Exactly. So for notation-wise, please remember y or f of x mean the same thing. You can say, why are we using 2 notations? Because sometimes this is more convenient than this. But they do mean the same thing. So this is indeed y. So when I'm told that y equals 2, what type of line is this? Very important to remember. What type of line is y equals 2? Yes, I know you're going to say straight line, but more than
Horizontal?
that. Yes, yes, yes. Excellent. So I will draw, or imagine I draw, but I prefer drawing. I draw y equals 2. I realize that this line crosses the function in 3 different points. So I will be reading this x value, I will be reading this x value, and I will be reading this x value. This is possible for a function, that 3 x's go to the same y, but not the same x to 2 or more different y values. So, can anyone give us when f of x is 2, we found 3 possibilities, x equals, x equals, x equals. I know it's difficult to read from my graph. I'm going to say negative 1.3. I'm going to say x equals 0. And I'm going to say I stretched it a little bit to make it nicer, x equals 3. And now if I ask you which ordered pairs did you read from, I know what you're going to say. Negative 1.3, comma 2, 0, comma 2, 3, comma 2. So negative 1.3, comma 2, 0, comma 2, and 3, comma 2. Any questions on how to identify points on the graph? Any questions? Anyone, please? Questions? Any questions? Okay. So let's go back to that graph. I'm going to make it a little bit different, tiny bit. Yes, I know you're going to say this is a function again. I'm going to put some numbers here. I'm going to say that this is 2, this is 2, this is negative 4, this is 6, and I'm going to say that this is negative 4. I just made up the numbers because we want to discuss this. Again, I'm going to ask, is it a function? Yes, you're going to say by the vertical line test, this is a function. I'm just going to say here 3. Few things I would like us to identify. X intercepts x-intercepts. What do x-intercepts mean? Can anyone say, oh, the x-intercepts are points where... Don't be shy, please. It's okay if you're wrong.
The line crosses X.
Yes. So I see 2 points. These are the x-intercepts. Can anyone give us the ordered pairs? I always tell my students, if you don't make a mistake, then why do you need me here? But I'm not asking you to make mistakes. So, can anyone tell us how to write the x-intercepts for this function?
Is it -3 and 0?
Thank you very much.
And 2, is that 2 and 0?
Excellent. These are the x-intercepts. Perfect. Something called y-intercept. Remember, a function cannot have more than one. A relation can have more than one y-intercept, but the function cannot. Only one. So can anyone read for us the y-intercept?
Is that 0, 2?
Brilliant. Thank you so much, Matthew. Good. Awesome. Very good. Now I would like us to identify domain and then range for this graph. Okay? So when I talk about domain, I go from left to right on the x-axis. And I imagine that I draw vertical lines. This vertical line does not hit the graph. So -6 cannot be in the domain. It starts hitting, my vertical lines start hitting the graph at -4. And they continue hitting, and yes, continue hitting till 6. Beyond 6, they don't. Because I specifically chose a full point, I will use brackets and write from -4 to +6. If this point or that point are open points, like this, I would have used the parenthesis for that point. But there I specifically chose full point. If I choose full point, I have to identify or present that domain using brackets. Can anyone discuss the range? And the range is the same, but this time I imagine that I try to cut the graph with horizontal lines, because now I have to read on the y-axis, not on the x-axis. Okay? So -6 is not in the range, because this line does not touch the graph. It starts at -4, and it continues, yes, no gap, yes, 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 till 2. Because this point exists, and this point exists, for the same reason, I will have to use brackets. From the smallest, from the lowest y value, to the largest y value. I consider that a 2. Also, what is important to understand when we look at a function, not just the x and y intercepts, not just the domain and range, we have additional properties that we have to identify about a function. Here are some other properties. Here's one. Increasing, decreasing intervals. Increasing, decreasing intervals. Okay, so follow my marker, please. The function starts here, and it goes up, and it goes up, and it goes up, and it goes up, till this point. Then it starts going down, and goes down, goes down, till this point. It turns again. It goes up, it goes up. When we talk about intervals of increasing and decreasing, we are not interested from what to what is increasing, or from what point till what point, or the y values. No, 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 no. We are interested in the x values. So you can say from 2010 till 2020, my salary increased. Not that it went from $20 an hour to $40 an hour. No. We are only interested to explain when the trend occurred. From 2010 to 2020, my salary went up. Then from this point till this point, something happened and it went down. Not from what value to which value. But the trend happened from 2010 to 2020, or from the age of 5 till the age of 7. Okay? So, and all these intervals have to be open intervals. Open means parentheses, closed means brackets. We do not use closed intervals for increasing, decreasing intervals.